Hi Year 13, so I'm going to go over this practice task that we did on Friday, and hopefully this will give you an idea of how to do it and what you need for achievement and excellence. Okay, so you've all had a chance to read this before. If you haven't, just pause here and read, but I'm going to jump straight into it. So we have Maria, who's making rose frames, and she's got these costs and materials that she's got to work within. So we'll just take it sentence by sentence and we'll see how we go. So our first bit of information starts here. Maria calculates that each medium frame only needs 600 millimeters length of timber and can be built in 4 minutes, while the large frame only needs 1200 millimeters of timber. She has a regular supply of suitable timber, a total length of 900 meters. So you'll just notice that I've ignored this minutes information for now because we want to deal with all of the same constraints at once. Minutes and length of timber are not related, so we'll deal with the length of timber first. The other thing that we'll just notice is that these lengths are in millimeters and the total length we've been given is in meters. So I'll just jot down here that that's 6 meters and that that's 12 meters, because it is important that we work in the same units. Okay, so I'll write that information as a constraint in a second, but what I'll say is I'll call medium frames, or the number of medium frames I make, I'll call that X, and the number of large frames I make, I'll call that Y. So in other words, 6 times X, and I'll write that down here, 6 times X plus, and it was 12 I think for Y, 12 times Y, 12 times Y, has to be less than or equal 900 meters. And that's our first constraint. Why is it less than or equal to 900 meters? Because her supply is only 900 meters, that's why. Maximum 8 hours a week. So now we can look at the time constraints. So the medium frames we're told can be built in 4 minutes, and the large frame in 6 minutes, and there are 8 hours in which to build those. So same again, we've got minutes for some, hours for others, so we'll change hours into minutes. So 8 hours we'll have to multiply by 60 to get into minutes, and that comes out as 480. So for those constraints we're going to have 4 times X, so 4X plus 6 times Y has to be less than or equal to 480. Okay, less than because 8 is all the time we've got, 8 hours or 480 minutes. Okay, so Maria contacts the manager of the local chain of hardware stores. The manager is willing to stock Maria's frames if she can guarantee at least 20 of each size per week. So at least 20 of each size, but will take no more than 60. So that means that for X and Y, whoops, why won't it get rid of that? Let's get rid of that. So here we go. Okay, so for X and Y, they both have to be more than 20, so X has to be bigger than or equal to 20, but it also has to be less than or equal to 60, so X has to be less than or equal to 60. So we could write that as one constraint by saying, well, X has to be bigger than 20, X has to be bigger than 20, but smaller than 60, and same with Y. Y would have to be the same, so I'll write those two constraints down here. So X is bigger than 20, X is bigger than 20, but it's also smaller than 60, and Y is bigger than 20, but also smaller than 60. Now these two constraints here, you can write them as 4 constraints if you want, but you just don't need to, so that's why I've written them like that. Okay, now we come to plotting these on our graph up here, and just as per usual, we've got our x-axis, and up here we've got our y-axis. So we're going to be plotting it like that, and a lot of you are having trouble working out how to plot this. Remember, plot like you're covering up one variable and solving that equation for the x. Okay, so if we're covering that up, we've got 900 divided by 6, and so that means our x-intercept is going to be 900 divided by 6, which is 150. We can do the same for y. So 900 divided by 12, that comes to 75. So our y-intercept for that one is going to be 75. Okay, so let's draw those two on. So 150 just there, and 75, 75 right there. It's not wanting me to draw. Okay, and then we'll rule those two together. So hopefully my ruler will work today. See how we get on. It's not too bad. Okay, so there's my first constraint. Now I should probably think about shading that constraint as well. So I'll just write my constraint here. So that's what is it? 6x plus 12y. So I'll just write that 6x plus 12y less than or equal to 900. To test my constraint, I'm just going to choose a point down here, 0, 0, and I'm going to put it in for my x and y variables. So that gives me 0 is less than or equal to 900. And I think to myself, well, is that statement true? And it is true. So that means that we want this side and we don't want this side. And it's the side that we don't want that we're going to shade out. So I'll shade everything on this side of my line. That's what I don't want. Everything else I want. Okay, let's go to my next constraint. And so that's 4x plus 6y, so I'll cancel out that. And that gives me my x-intercept, so 480 divided by x, so by 4. So my x-intercept here, 480 divided by 4 is 120. And then I'll do the same for my y-intercept. So divide both sides by 6, and my y-intercept is going to be 80. Okay, so let's come and put that onto our graph up the top. So x-intercept was 120, so that's just there, and y-intercept was 80, so that's there. We'll rule that in. This is the hardest bit on the tablet. Here we go. It's not too bad. I might just do that again. Okay, let's see how we go. That's about as good as we'll get. Obviously, on paper, you need to be really, really accurate. Okay, so that one there is our 4x plus 6y is less than or equal to 480. And same as I did up here, I'm going to put 0 in for my point, 0, 0. And so I've got to ask myself, is 0 less than or equal to 480? And yes, it is less than or equal to 480. So that means I want this side, and I do not want this side. I just realized that I wrote do want last time. I meant to write do not want. So I don't want that side, so I'll shade it out. So let's shade this side as well. So all of that stuff there shades out. Okay. So our last set of constraints is just saying that x has to be between 20 and 30, and same with y has to be between 20 and 30. So for both x and y, I'm going to have to draw a line at 20 and draw a line at 30. That's not what I'm after. Let's try that again. Alright, so there's my line, my attempted line at 20, there we go. And we'll need another line at 60. Okay, here's my 60. Okay, and same for Y, I need one line at 20. There we go, and one line at 60. I really have to stress the importance of being accurate, and you know, it's hard when I'm trying to model it on a touch screen, but when you guys have paper you should have a much better chance of modelling it. Alright, with both those things we want this bit between 20 and 60, so we want that bit, and we don't want those bits on either side, so don't want those. And so it's the don't wants that we're going to shade. So after I've tidied that up, we're going to shade the bits that we didn't want. So all of this side is don't want, and all of this side was don't want. And it's the same with my Y. Everything less than 20 I don't want, so I'm going to shade it out. And everything more than 60 I don't want, so I'm going to shade that out as well. Okay, so we're left with this region, and one thing I've noticed some of you do is you colour in that region so that you can clearly see it. You're welcome to do that, just make sure it doesn't make your graph too messy, but it can help you highlight your region there. Okay, so when we get to this point, we want to look at maximising our profit function. Now we haven't actually talked about that yet, so let's just go back up to our question here, and we were given some information here about the profit. So the deal will give Maria a $6 profit on each medium frame, so 6 times X, and $10 profit on the Y frames. So I'll just call that function P because that's our profit, and that's the function that we want to maximize. So I might even just write that underneath my constraints here. So we want to maximize P equals 4x plus, no, it was 6x, wasn't it? 6x plus 10y. And to do that we need to look at each of these points, so colour them in with a different colour. So every vertex we want to look at. Okay, now some of these vertices are trivial, like this one down here. I'll label them A, B, C. So A, B, C, D, E. Okay, so A is trivial, that's just going to be 20, 20. Okay, because we know from our constraints. Same with B. B is going to be 20, 60. C isn't quite so trivial, but E is trivial, that's going to be 60, 20. And it's just those other two, D and C, that we need to actually work out. So I'll just make a little table underneath here, where I'll have my point and its coordinates, and the profit function. So profit function, and what it's equal to. Alright, so let's just make this up. So we've got our points A, B, C, D, E, and we did A first, which came out as 20, 20. So that's 20, 20. Then we did B, 6, and then E, other E's one, which was 60, 20. So we need to work out B and C. C and D. So C's not, that seems to be the crossing over of the two diagonal lines, and also where y is 60. So we could choose either of the diagonal lines there. So I'll choose the easiest one, which is 4x plus 6y is less than or equal to 400, but I'll just 480, but I'll just write equals, and I'll put in the y value because I know that it's 60. So I can say 4x plus 6 times 60 equals 480. So that's 4x plus 360 equals 480. So subtract that from both sides, so 4x equals 120. Divide both sides by 4, so x equals 30. So that one's going to be 3060. So I'll put that in, 3060. And then the next point is where this diagonal crosses with so same again. I have 6y equals 480, and I'm going to put 60 in for x, so 4 times 60 plus 6y equals 480, so that's 240 plus 6y equals 480, so 6y equals 240, divide both sides by 6, so y equals 60. Sorry, y equals 40. I'll fix that up. 40. Okay, so for that point we've got 60, 40. So D is 60, 40. So let's put that into our table. 60, 40. Alright, so with each of these we want to put it into our profit function, which we've got written up here. 6x plus 10y, so we're going to have 6 times 20 plus 10 times 20, which works out to be, I'll work that out in a second, then 6 times 20 plus 10 times 60, and 6 times 30 plus 10 times 60 plus 6 times 60 plus 10 times 40, and 6 times 60 plus 10 times 20. Okay, so we want to put all of those into our calculator and work out what we get for each. So here we get, so 2020 we get $320, and 2060 we get what's that? 2060 is, well, hang on, I'll do 3060 first, that's 780. 2060 is 720. Then 6040 is 760. And 6020 gives us 560. Okay, so we look at all of these and we decide which one gives us the maximum profit, and that biggest number here is 780, and so that's our max profit there. Now we need to just interpret this a little bit for our assessment, and so I'll just write a sentence that really summarizes that. So I'll just say profit is maximized at point C, which is 3060, with a profit of $780. Now that's just a very simple interpretation. We really ought to put it in context, and just remember that X is the number of medium size frames and Y is the number of large. So let's just interpret that in terms of medium and large frames. So Maria should make 30 medium frames, and 60 large size frames to get a maximum profit of $780. Okay, alright, so if you can get to this point, that is achieved. Alright, that's the minimum that you need to be able to get achieved. So just summarizing, you need to be able to read a situation like this, write some constraints, then you need to be able to, and you need to valid points to get a maximum over here, and then interpret them to what it actually means. So that's achieved. I'll finish this video here, and then in my next video I'll do merit and excellence.